Hi. As stated in my email, my water pump is out and someone's coming tomorrow to repair it. So I um, I have to I, I have to attend to that. Um, but we're continuing with the same topic, which is solving inequalities. I know that it's complicated, meaning there are a lot of steps. So hopefully this will be helpful. Um, The question number one is the one I would suggest doing at the for you when if you're working through this, do this at the very end. Um, I- am I like this problem a whole lot. Um, it translates everyday words and experiences that we've had into inequalities. And it also has this benefit that this is actually what investigators do when there is an accident. Skid marks, right? The skid marks correspond to when braking began and braking ended, and using that information to determine how fast um, a vehicle was traveling. So this is a small touch of the real world. It's a much more complicated problem. Braking distance depends on the kind of vehicle, the kind of tires, the kind of surface conditions. So it's much more complicated, but it's a little touch of reality. But it is certainly not the focus. Rather, there are two problems here that are sophisticated. These are problems, that require attention, that are more than just one step, and um, and so they're not fundamentally any different. There is nothing different. It's just bookkeeping, attention. The last problem is, again, a bit of an applied problem. The numbers are reasonable in terms of things that can actually happen on the Earth. The number negative 4.9 here in the bottom corresponds to the acceleration due to gravity. This corresponds to 30 meters per second launch velocity, which model rockets have no problem achieving. So this is all a very realistic problem. So anyway, but I'm going to do problems 2, 3, and 4. And I will post all of this, the documents also on Canvas. And then this should be available. I should be able to get this to post on YouTube. Anyway, on to this. All right, so question one is x times the quantity x minus 1 all over x plus 3 squared times x minus 2. So numerator, denominator, when is it less than or equal to 0? Well, first step is always set the whole thing to 0, or excuse me, exchange the inequality symbol with equality. And by the way, just a note, from now on in, I will only have 0 here, so you don't have to multiply, or you don't have to do a lot of fiddling around. That's can be distracting. So how do I deal with an equation that involves fractions? Multiply both sides by the denominator, which I've done here. This reduces. This is 0. So I get x times x minus 1 equals 0. 0 property of multiplication, x is 0, x minus 1 is 0. So I have the two numbers that solve my equality, my equation, are 0 and 1. Does not exist? Absolutely. Is the denominator 0? Denominator 0? Yes, that means that either x plus 3 quantity squared is 0 or x minus 2 is equal to 0. In the first case, x is negative 3, and in the second case, x is 2. So I have 4 numbers. And here they are, negative 3, 0 from up here, 1 and 2. And you can see my little scissors. And then the little tiny numbers below, those are my test numbers, right? You can see they're in this interval. Here are my intervals, negative infinity to negative 3. Negative 3 gets parentheses because it comes from does not exist. So negative 3 to 0. 0 gets bracket because it comes from equation, and the original has has equality in it. And then 0 to 1. 1 is also from the equation, which then matches up with the original. And 1 to 2. Let's see, 2 is from does not exist, so it's parentheses and then from 2, 1. So I have 4 values, and that means I have 1, 2, 3, 4, 5 intervals. And I test each interval. What do? I take -4, that's my test value over here, plug it into the original, and ask, is that, whatever that is, calculator, boop, 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 is that less than or equal to 0? Yes, it is. How about this one? So that interval will be, yep, I'm going to include that. This one here, plug in -1, that's my test value. Is that less than, and then boop, 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 is that less than 0? Yes, it is, true. How about 0.5 here? Plug that in. Boop, boop, boop. Is that less than 0? No, no, no. How about 1.5? Plug that in. Yep, it is. And then 3? No, 3 isn't. Okay, so I just put together the intervals that are true, for which this is true. This interval, right? Because -4, it corresponds to this interval, true. -1, that's this interval. Oh, the next one, this interval, okay. And then 1.5 corresponds to this interval, 1 to 2, right there. Those are them. That's the solution. It's those 3 intervals, okay. So all 3 of these problems are going to follow exactly the same pattern. All right. So x squared over x minus 5 times x plus 2 greater than or equal to 0. Replace inequality with equality. Multiply both sides by the denominator. I get x squared equals 0, which implies that x is 0. So that's my equation number. Does not exist? Absolutely. X minus 5 over, or times x plus 2 is 0. Either x minus 5 is 0, or x plus 2 is 0. In which case x is 5 and -2. So 5 and -2 come from does not exist, parentheses. 0 comes from the original, which has an equal, so that's going to get a bracket. So here I have -2, parentheses, 0, bracket, 5 does not exist, parentheses. Okay, so my intervals, everything up to -2, between -2 and 0, parentheses, brackets, between 0 and 5, bracket, parentheses, and then from 5 on, parentheses, to infinity. And then I test, and here I've just put down here, just for me, my little test values, like -3 is going to be for the first interval, -1 for the second, 1 for the third, and 6 for the last interval. So I plug in, just take these, put them into the original inequality, and see, do these numbers work in the original inequality, true or false? And they work, true. -1, plug it in, doesn't work. 1, doesn't work. 6, yep, that works. Okay, so I have -3, that's over here, that's associated with this interval, true, so there's that. And then 6 is this interval, that's this one, so the 2 intervals. And where does this come from? This means the set of just one number, 0. That's it, just one number, no interval, right? You can see both of these intervals are false, don't work, right? But these intervals, bracket, literally bracket, 0, right? From -2 to 0, bracket, from 0 to 5, bracket, at 0, right? And since the original inequality includes greater than or equal to, we know that at the endpoints it works. It just doesn't work on either side of the endpoint. So I have to include this. So the set notation to say, yeah, that one point works. Since the original is greater than or equal to, and both intervals, bracketing that 0, are false, just the endpoint works. So I'm going to, I'm not going to not doing nothing. Okay, I'll come back to that. All right, but you can see the process is the same. Now let's even look at the next one, and I want to. It's 10 minutes. That's certainly as much time as is reasonable here. But number 4 here. During what time intervals for which times is this projectile above at least 20 feet or 20 meters off the ground? So h of t negative point. Here's the formula for the height at any time t at least means greater than or equal to. So here's, then I replace it with equality, subtract 20 from both sides, and guess what I did here? Yes, I used my calculator. And of course, there's no does not exist because it's a polynomial. And excuse me, here are my 2 intervals, or 2 endpoints, and my 3 intervals, and my 0, 1, and 6 are my test points. Here are my intervals, all brackets, because at least means greater than or equal to. Here are my test numbers, plug them in, false, true, false. So between 0.63 seconds and 5.49 seconds, the projectile is at least 20 meters above the ground. Right. All right. Good. Well, I hope that's helpful. We'll practice a little bit more when I get